right. Yeah. So here we are with question 6 about straight lines. Quite a nice one to do actually, because I think there's a really interesting thing happens in part 3 from what I remember of this one, just glancing at it. So part 1. The line joining the points minus 27 and minus 4p has gradient 4. Find the value of p. We've just made a big thing about knowing that gradient is going to be the change in the y values over the change in the x values. So the gradient here is going to be the change in y, so p minus 7 over the change in x, minus 4 minus 2 is equal to 4. It's funny how every time I do this, each year, I didn't do one of these last year, but each other year that I've done this, there's always been one kind of thing that I pick up on that feels like it becomes a big deal in Core 1. And, you know, as you've seen again, we've got a negative number thing going on that we've got to be careful of. Actually, that's one of those common things that you get all the time. So we've ended up with p minus 7, we don't want equals then. P minus 7, now that would be divided by minus 2, because we've got minus 4 plus the 2, minus 2 is 4, so P minus 7 equals negative 8. I'll multiply both sides by minus 2, giving me P is minus 1. There we go, are we happy with that? The line segment joining two other points, minus 2, 7 and 6, Q, has midpoint M5. Find M and Q. All right. So that tells us, well, if we do the midpoint of the x values, the midpoint of the x values is minus 2 plus 6 over 2, and that's equal to M. So that, I think, gives me minus 2 plus 6 is 4, divided by 2 is 2. I've come up with 2 for that. And the other one, 7 plus Q divided by 2 is equal to 5. So 7 plus Q must be 10. So Q equals 3. That 3 marks, dead easy really, just about knowing how to find the midpoint of two lines. It's not on the formula sheet, but it is on your poster on your bedroom wall. Part 3. The line segment joining the points minus 2, 7 and D3 has length 2 root 13. Find the two possible values of D. Just take a second to think about how you might go about doing this. And I can think of 2 ways to do this. And the first way is the way that you were probably intended to do this. So anybody got an instinct about what they would do with this? Okay, and then use the length of the line formula, the Pythagoras thing. I think that's a pretty good idea. So, I reckon this is the way they intended you to do this, but I think there's another way of doing this question. So minus 2, 7 and D13. And the length was 2 root 13, wasn't it? And so if we put that into the formula, then that says that the square root of it's D3, thank you. D3, not 13. There. Is that right now? Right, so that's going to be D minus 2 squared plus 3 minus 7 squared is equal to 2 root 13 squared. No, it's equal to 2 root 13, not 2 root 13 squared. Sorry. Right, so we're there. I'm going to get rid of the square root sign by squaring both sides. So we will turn this into 2 root 13 squared in a moment. This is d plus 2 all squared plus minus 4 squared is equal to 4 times 13. Oh, I ran out. There we are. If we square 2 root 13, we get 4 times 13. So we've got, you can solve this however you like. So you may want to just multiply everything out, collect everything together, and bring it all together. I'm thinking what I might do is keep this as being d plus 2 squared, because that's not a bad thing to have, and have this as being 4 times 13, which is 52, minus the 16 that I've got from there. So d plus 2 all squared is 36, which gives me d plus 2 is plus or minus 6 at the square root. And so d is minus 2 plus or minus 6, which gives me minus 8 or 4 as my two answers. And there we go. We've done it that way. Which isn't a bad thing to do for 4 marks. But I do wonder about this as an alternative. So we've got a straight line somewhere. And we've got a point on that straight line with coordinates minus 2, 7. And we're told that there is another point that is 2 root 13 away with y coordinate 3, or with coordinate 3, hang on. And we want to find, so we've got another point, where's my, my line will be different to this. Yeah, there would be, where's, oh no, can't draw a line here. I knew this was going to come unstuck with doing it on this board. Right. There we are. Right. So this other point, there's the line, and this other point that I've got is down here somewhere. Okay? And I know that this distance along there is a distance of 2 root 13. And this distance along there is a distance of 2 root 13. Because that's what the question told me. And I know that this distance here is equal to 4. I know that's equal to 4 because these points are with coordinates d3. So that gap there is 4. Does that make sense? Now, if that gap there is 4, I could now just use my little Pythagoras theorem with the triangles. There's a triangle there with the black line on it, and there's a triangle there with the purple line on it. And if I look at those triangles by Pythagoras' theorem, let's call this distance A. I know that A squared plus 4 squared is equal to 2 root 13 squared. So A squared plus 16 is 2 times root 13 squared, which is 4 times 13 squared. Is that right? No, 4 times 13, so it's 52. So A squared is 36. So A is plus or minus 6. So that gives me either, well, that distance is 6 and that distance is 6. So I do minus 2, take away the 6 to get the first one. Give me minus 8, and I do the minus 2 plus the 6 to get the other one, which gives me the 4. And so I could have done it with a purely kind of graphical method of thinking how this all makes sense graphically as an alternative, instead of doing all the stuff at the top. They are very definitely two alternative ways of doing it. I'm not suggesting it's one more than the other, but I think maybe that's a slightly easier 4 marks than the first bit if you see it. Okay, and that's maths.